Imagine a universe where everything is predetermined, existing in just one unchanging state. How could life, consciousness, or even the passage of time exist in such a static reality? This mind-bending concept lies at the heart of a groundbreaking new quantum gravity paper, and is sparking both fascination and debate among scientists and enthusiasts alike. But here's where it gets controversial. The paper suggests that in a universe governed by a one-dimensional Hilbert space, external observers, like us, shouldn't even exist. So, how do we? Let's dive in. Quantum mechanics and general relativity are the twin pillars of modern physics, each triumphantly explaining the behavior of the universe at the smallest and largest scales, respectively. Yet, these theories stubbornly refuse to work together, particularly when it comes to black holes and the Big Bang. And this is the part most people miss. Reconciling these two giants is the holy grail of physics, often called the theory of everything. But despite decades of effort, the quest remains unfinished. The challenge is immense. Most proposed theories, like string theory and loop quantum gravity, are mathematically elegant but experimentally untestable, at least for now. String theory reimagines fundamental particles as tiny, vibrating strings, while loop quantum gravity suggests space itself is composed of indivisible chunks woven into loops. Then there's the bold idea that gravity emerges from entropy, a concept that flips traditional thinking on its head. Each approach is a fascinating attempt to bridge the quantum and the cosmic, but none has yet emerged as the clear winner. Enter the new paper by Daniel Harlow, Michailo Yusutiak, and Ying Zhao, which tackles the Hilbert space of quantum gravity. For the uninitiated, Hilbert space is a mathematical framework that extends our familiar 3D geometry into infinite dimensions. When applied to a closed universe, one that might eventually collapse in a big crunch, something strange emerges. The Hilbert space becomes one-dimensional. The implication? Such a universe couldn't support external observers. As Professor Brian Cox cheekily noted on social media, the paper includes a footnote that leaves the theological implications as an exercise for the reader. But don't worry, this isn't about proving or disproving divine intervention. Instead, it's a deep dive into the nature of existence itself. The paper explores how observers like us could fit into this one-dimensional universe using holographic principles. Think of a hologram, a flat surface containing all the information of a 3D object. Could our reality be a projection from a simpler, underlying structure? This idea isn't just philosophical, it could have practical applications, particularly in black hole physics. Even if it doesn't fully unify relativity and quantum mechanics, the paper's footnote alone is destined for scientific legend. While the preprint, available on AR14, https://arx4.org/apps/2501.02359, is dense and technical, its implications are profoundly accessible. It challenges us to rethink the very foundations of our existence and the universe we inhabit. But here's the real question: if our universe is fundamentally one-dimensional, what does that say about the nature of reality, and our place within it? Let us know your thoughts in the comments. Are we living in a holographic projection, or is there more to the story? The debate is wide open, and your perspective could be the next piece of the puzzle.